right, good morning and welcome once again to our class, MAMU with Jarvis. And this is our grade 10 experience. We'll be looking at geometry, and we said that for the purpose of these discussions we'll be having, we've broken maths into three key aspects: geometry, algebra, and arithmetic. So this is a geometry aspect of this discussion. And our textbook of reference remains Essential Mathematics for Grade 10. Essential Mathematics for Grade 10, that's your SS1. And then we'll trust you can get this book because that's what we'll be using as our reference text as we go on in this course. So having said all of this, we want you to check our page out on YouTube, MAMU with Jarvis. Lots of materials have been uploaded there, and we want you to go there, look at them. The essence of MAMU with Jarvis is for students to be able to have, to control the teacher. You know, most time in class, the teacher controls you, but with technology today and with YouTube, you can actually control the teacher. How? You can stop the video, you can rewind, you can go forward. You're controlling the teacher, so you have access to what you want per time. So let's get down to work today as we look at geometry, looking at theorems. Okay, so we'll be looking at page 194 of our textbook. Remember that the last thing we treated under geometry was that of triangles. We've looked at triangles, but now we'll be looking at theorem or theorems. Now, the build-up of our concept of theorems will kickstart from our knowledge of triangles. Now, there's something we call deductive reasoning. Deductive in the sense that we have established rules that enable us to solve problems based on conclusions that have been drawn. So what exactly does the theorem or theorems in maths give to us? They are established geometrical principles that help us to solve problems. We'll kickstart the understanding of geometry by looking at the triangle. So we'll pick the triangle, and from that, we're going to be looking at 2 or 3 theorems from there. Now let's look at the triangle. Now this is a triangle. Let's call it A, B, C. Now a triangle we have established has 3 angles, is that not? Yes. Now we have said that the sum, if this is A, this is B, and this is C, we have established that the sum of the angles, the first theorem you need to take note of, so let's call it more like a theorem 1, is that the sum of angles, of the interior angles of a triangle is 180 degrees. That's an established fact and a theorem that what? The sum of the interior angles of a triangle add up to what? 180 degrees. Is that clear? I've called it theorem 1, but like I always tell students when I teach concepts here, I take my own approach. I take my own approach to the matter. The reason being that it's not just your ability to memorize the theorem that is the issue. You need to know, identify them, and know when to use them. So the identification of the theorem and knowing when to use the theorem becomes more important than knowing the theorem. All right, so this is theorem 1. What it's saying is that angle A plus angle B plus angle C will be equal to what? 180 degrees. So that's what the first theorem is stating. Now, the next theorem I'll consider under the triangle, maybe I should have had this as a heading, triangles, would be that the sum of the exterior angles angles, the sum of exterior angles of the sum of the exterior angles of a triangle is equal to 300 is what? 360 degrees. This theorem holds true for all polygons. So it's not just respect to triangles. We just had to make that a special case arrangement. Now, the next one that is so important, which I will call my theorem 3, is that the exterior angle of a triangle is equal to the sum of the two opposite angles. Now, we will need to have a picture of that concept. We need to have a picture of that concept. Now, look at what it's talking about. If I have this A, B, C, and let's say I call this X, Y, Z, and let's call this W. What the theorem is saying is that this is an exterior angle. And that this exterior angle W will be equal to the sum of the what? Two opposite interiors. Sorry, I said opposite interiors. Sorry about that. Opposite interior angles. Now, these two angles are interior angles, and this is the these are interior opposite angles to this. Please take note of that. These two angles are opposite interior angles to what? This one. So we would say that X plus Y is equal to what? W. And we write this as what? Exterior angle of triangle. Please take note of my shorthand. I love to use shorthand a lot when I deal with geometry. So take note of my shorthand. Exterior, symbol for angle of what? Triangle. Now take note of this. For this one, our rule is going to be angle sum of triangle. Angle sum of triangle. I'll give us time to allow this settle and then we'll continue. So we'll try to go into solving questions as it regards triangle. What we just treated about the major laws, you're going to major theorems. Sorry. Now, I think it escaped me to talk about a theorem. A theorem is a mathematical rule or proposition that can be what? Proved or validated by what? Argument or logical reasoning. That's what a theorem is. Sorry, I didn't make mention of that. So you validate a mathematical proposition or concept by argument or via what? Logical reasoning. You find theorems very, very useful in geometry. Theorems are very, very useful in geometry. Now, having said that, we will need to go to handle some practice exercise. And to help us with that, still on our textbook, we'll look at page 198, exercise 15.2. Exercise 15.2, quite a number of questions there, and then we'll try to see how that will help us to make concrete the knowledge we have gathered. Now look at the first one there. Exercise 15.2. And that will be find the values of the angles marked with letters in the diagram. Now in A, this is the diagram you have for A. Okay, 25 degrees, 20 degrees, and 87 degrees. Okay, We are told to look for what? X. So how do you look for X in this diagram? Now, except you know what you're doing here, it might be difficult for you to make a decision on what you need to do. But I'll help you out by showing you options you can follow. Now, you can choose to join this to this point so that you have, remember, so that when I add these two angles, I can get this one. And when I add these two angles, I can get this. I come again. You can choose to join this way so that if I add these two angles, opposite interior will give me the exterior. And when I add these two, this angle, let me call it A, is exterior to this triangle. And then these two angles are exterior to what? X. Have you seen it? So that's the first thing you need to take care of. Once you're able to know what to join, it becomes easy for you to solve the problem. So from this, we will say that what? Using notations, always tell the examiner using notations as in diagram. Using notations as a diagram, we have that 25 plus 87 degrees will be equal to what? A. And we'll call that exterior angle of what? Triangle. So with that, A will be equal to what? When you add this, will be 112 degrees. I seen that. That becomes 112 degrees. So these two angles are interior angles and this angle is exterior to these two angles. So what do you have? You have A plus 20 being equal to what? X. And the same reason would apply. That is what? Exterior angle of what? Triangle. So what is A? A is 112 plus 20 equal to X. And X will be equal to 132 degrees. So with that, you've taken care of question 1A. Let's go to question 1B. In 1B, this is what you have. Okay, so this is A. Now this is a figure we have. And if you look at this carefully, this question is going to be combining a previous knowledge we gathered with an idea we need to take care of. So in starting this, I will call this, remember I'm looking for A with that. I'm looking for A and B. I know this. I know this. I need to look for these two. So this one I've introduced. Now, using notations, as in diagram, you understand that this symbol tells us that these lines are parallel. And there is a relationship between this angle 110 and X. What's the relationship? They are said to be what? Co-interior or allied angles. And from our basic knowledge of parallel lines having a transversal cutting through, we know that co-interior angles or allied angles are what? They sum up to 180 degrees. That is, they are supplementary. So if that is understood, we now know that X plus 110 will be equal to what? 180 degrees. And the reason is what? Allied angles. They are allied angles. As such, X will now be equal to 180 minus 110. And that will be 70 degrees. So with that said, B will be equal to X. B will be equal to X. What's the reason for that? They are said to be what? Vertically opposite angles. They are vertically opposite angles. So what is X? X is 70. So B will invariably also be what? 70 degrees. Now, look at this. These two angles are interior angles to what? Opposite interior angles to what? 130 degrees. So we would say that A plus B will be 130 degrees. And what's the reason for that? Exterior angle of what? Triangle. That's it. So we know what B is. B is 70. So A plus 70 will be 130 degrees. And A very will be equal to what? 130 minus 70. And that will give us what? 60 degrees. So that's the answer to that question. So that's for question 1B. All right, so now in question 2, you are told that three angles of a triangle. So the first thing you need to do is to draw. Let me add at this point that one way you succeed in this aspect of maths, in geometry, is to develop a culture of drawing. You must draw. The picture is always absolute. I read that from a book. The picture is always what? Absolute. When you draw, drawing is a way of enhancing your imagination. So draw that, and they say one of the angles is what? X, the other is 2x, and the last one is what? 3x. It says find the value of x and hence find the angles. Now we know that the sum of the angles of a triangle is what? 360 degrees. So you say using notations as in diagram, comma, you have that x plus 2x plus 3x will be equal to 180 degrees. The reason is angle sum of triangle. Now, I noticed that whether out of omission, I have not told us the importance of these things I'm writing. For one, a number of reasons. One, the marks you earn in this aspect of maths are tied to your reason. It's just like this is the mathematical law. Here you are a lawyer. I prove it to you. You have to quote. Here, math is like a law course in geometry. Math is like, especially in formal geometry, which has to do with solving problems by deductive reasoning and profiling arguments and reason. What you need to take note of here is that each of the rules you put forward must be backed by a logical reasoning. If I just state this and I don't state this, I earn no mark. Do you understand? 1 minute. Okay, so this theorem, these reasons you're seeing here are very, very important, and they must be quoted correctly. If you don't quote them correctly, you earn no mark, and your argument is not valid. So to what? 180 degrees. So every answer is more like a theorem. Equal to 180 degrees, and x will be equal to 180 divided by 6, and that will be 30 degrees. Are you seeing that? Now, you have to be careful. You were not told to just find x alone. You were told to find the other angle. So we now know that one of the angles is what? 30 degrees. The other angle is 2x. The other will be what? So these are the angles we are what? Looking for. So when you're solving problems, be very careful to read the question through. Don't rush to solve and understand what the question requires of you and nail it. Let's go to question 3. Question 3 says, three angles of a triangle are 5x minus 7, 2x plus 15, and 2x plus what? 1. It says find the value of x and hence find the largest and the smallest angle. This is another very simple question. We know that 5x minus 7 plus 2x plus 15 plus 2x plus 1 is equal to 180 degrees. What is the reason for that? Angle sum of triangle. Notice that while writing them, I case them all in a bracket. In my next line, I'm going to write everything out. Okay, now, previously I teach my students to collect like terms. I'll tell you collect like terms and whatever, but I discovered that with modern mathematics, some of these things are becoming monotonous. Some students stay in a particular method, and by the time you try to push them out of that to something else, they are struggling. So I discovered that the best way is to create a random approach. So you can actually do this randomly. This is positive 5x, positive 2x, positive 2x. You can add them, and that will give you what? 9x. Now, this is negative 7, but I have 15 here. 15 minus 7 will give me what? 8. 8 plus 1 will give me what? 9. Equal to 180 degrees. Now, I think I have a video for grade 7 called the Introduction to Algebra. You may want to go back to my grade 7 work and look at what I've done in algebra. Those explanations are very, very simple and fundamental. So go to MAMU with Jarvis on YouTube and watch these videos again. And I think there, in some of those installments, I try to use that new approach to teaching algebra now. So you don't have to always arrange. It's not every time. Now, I've always told us that it's not to know the principle that is important. You need to know when and how to use them. The when and how to use them becomes very important in modern maths. So that we don't just pack a lot of theorems up here and we don't know how to use them. All right. So with that, here I'm going to change an approach here too. If you watch this figure very well, you discover that there is a common factor that can divide everything, and that is 9. So instead of say you move to this other side and then you cancel, I would rather say this 9 into x plus 1 equal to 180 degrees by way of what? Factorization. And as such, 9 go here 1, 9 go here will give me what? 20. So x plus 1 will be equal to 20. And x will be equal to what? 20 minus 1, which is equal to 19 degrees. Now, the beautiful thing about this is that it gives you an opportunity to know when to use an idea or not. It's discovered here that there's something you have seen here too, and helps you to predict what the examiner wants from you per time. Now, the question says we should find the largest and the smallest angle. Now, you can't tell the largest by looking at them. So what you do, you start with 2x plus 1. I'll start with that. And that'll be what? 2 into what? 19 plus 1. And what does that give you? 38 plus 1, which is 39 degrees. Pick the next one. 2x plus 15 equal to 2 into what? 19 plus 15. And that will give you 38 plus 15. And that is what? 53. I've seen that. Then the last one is 5x minus 7, which will be what? 5 times 19 minus 7. What does that give you? That will give you 95 minus 7. And that will give you 88 degrees. So you discover that this is the largest and this is the smallest. So largest, and this will be what? The smallest. Are we together? Okay, so that will be the size of the class for this morning. Like I did explain when we started, it's so much of how much we are covering, but how well you understand these concepts. The questions you will solve will necessarily revolve around these ideas. So I wish you a fruitful stay in this new academic session, trusting that we will still be making videos, and when you're back for your long break, Christmas celebration, we'll be able to give you useful videos that would help you. But I will not stop making videos daily, and once you're back, you have enough videos to watch. Enough videos to watch. MAMU will always return. And to end today's class, I will leave you with one thought. It takes two things to become an outstanding mathematician. You really need to have an interest in maths, and two, you must make it a habit to always practice. Have these two, and you are not far away from becoming an outstanding mathematician. I'll leave you and trust that you put yourselves together as we get back to business this session. Thank you very much.